lesson we're going to look at finding the area of triangles and given different pieces of information. Now in grade school we learned that the area, and we always used in grade school, we used A for area. Sometimes we will use the letter K to represent area since A is also an angle. And then sometimes we use a capital letter S for area. So area is equal to 1/2 the base times the height. That's our basic formula for area. Well, we want to look at how we can do this without having to find the height. And then sometimes in the past we would have to solve that. So we've got us a triangle that I've dropped a altitude, which we know is perpendicular to the base. So from this we could find that the sine of angle B is equal to h over A for this triangle. So A sine B equals the height. Well, if we took our triangle, our formula now, our area is equal to 1/2, and for this triangle, C is the base, and then times the height, which we now know to be A sine B. So instead of having to find the height, we found the area based upon two sides and the sine of the included angle. If we went to this other triangle, we know that the sine of A would equal h over B, and so we could find that the area was equal to 1/2 the base, which is C, times B sine A, if we solve that for h. And so again, we found that the area was equal to the product of the two sides times the sine of the included angle. And we could go up and we could drop our altitude to a different base, and we would find that the area was equal to 1/2 AB times the sine of angle C. So here's a formula then for finding the area of a triangle based upon two sides and the included angle. So it's the product of the two sides times the sine of the included angle. And we can find our area. So let's look at a problem. Here we have that we have side A, side B, and side C. If we draw us a triangle, we have that side A is 76.3. Side C is 42.8. And angle B is 16.3 degrees. So we have two sides and the included angle. So we can find our area. It's equal to 1/2 the product of the two sides times the sine of the included angle. So 1/2 times the product of the two sides times the sine of the included angle. And so our area would be 458 square feet. So that's a fairly straightforward and simple way of finding the area given two sides and the included angle. Okay, we want to look at, well, what about if we were given two angles and a side? and we want to see what happens. So we have us a triangle. And let's say in this one we were given two angles and a side. So let's say we were given angle A, angle B, and any of the sides. So let's say side A. And we want to see how we could go about solving this. Well, if we're given angle A and angle B, we know we can find side C, angle C. And we know then from the law of sines that we could find one of our other sides. So let's say that the sine of angle A is to side A and it doesn't matter which one we find. Let's say the sine of angle B is to side B. So we could find side B is equal to A sine B divided by the sine of A. So now we know side B. It's A sine B divided by sine A. So now we have two sides in the included angle. So if we go back to our formula, if you remember, it was 1/2 the product of the two sides. Well, we were given side A. We found that side B was A times the sine of B divided by the sine of A, and then the sine of the included angle Okay, once again, I've labeled my sides wrong. I've done that several times. This would be side B. So let me erase this. And go back. And what we still had was true. The sine of A is to side A, as the sine of B is to side B. And so B is A sine B sine A. All of that's still correct. What I'm doing now is I have two sides in the included angle. My included angle is angle C. And I was doing that incorrectly down here. So all that's going to change is right here, this is going to be sine C. Now, if we go through and we kind of clean this up, multiplying my numerators, what I have is A squared times the sine of angle B, sine of angle C, divided by 2 sine A. And I've got my area based upon knowing only one side. I had to know two angles, and if I know two angles, then I can automatically find the third angle. So we could also do this formula. We could go back and we could do it again, but we would get that it could be, if we were given side B, then it's going to be B squared sine A sine C divided by 2 sine B. These are the two angles. Side B is between these two angles. So it's two angles in the included side, then divided by twice the sine of that angle. If we were given side C, then it would be C squared times the sine of A times the sine of B divided by 2 sine C. So in this case, we know two angles and the included side. Now, that may not be what we're given, but we can always find the third angle, so we use the two angles and the included side, and it's the side squared times the sine product of the sines of the included angles, the two adjacent angles divided by twice the sine of the opposite angle. Okay, let's look at a problem where we would use that. Drawing our triangle, we're given that angle B is 57, angle C is 31 and side A is 7.3. So we were given two angles and a side. Now it didn't matter which side I was given. I could be given any of the sides because I can find my third angle. Angle A is going to be 180 minus 57 minus 31. So angle A is 92 degrees. So no matter which side you're given, you know all three angles, and the side is going to be between two of those angles. So the area is equal to the side squared times the product of the sines of those adjacent angles divided by twice the sine of the opposite angle. Now, when we go to put this in our calculator, remember we're going to have to put the numerator in parentheses and the denominator in parentheses. And we also need to remember that our calculator will open this angle, so we have to close it. It opens the angle, we have to close it. Okay, let's put this into our calculator. We'll have parentheses, then 7.3 squared times the sine of 57, close the angle, sine of 31, close the angle, close the numerator, divided by, open the denominator, 2 sine 92, close the angle, close the denominator. So our area would be 11.5 square meters. So again, that's a fairly easy formula to use. The third thing that we want to look at is when we're given three sides. So we looked at given two sides in the included angle, given two angles in any side, and now we want to look at given three sides. And for this, we're going to use what's called Heron's formula. Now, I'm not going to go through and prove Heron's formula. It's fairly long and involved in proving it, but Heron's formula simply says that the area is equal to the square root of s, that's a little s, times s minus a times s minus b times s minus c, where s is what we call the semi-perimeter. It's the sum of the sides divided by 2. Semi meaning half. It's half the perimeter. And that's Heron's formula. It's just a matter of substituting in. So if we have that side A is 48 feet, side B is 75 feet, and side C is 63 feet. We want the area. Well, the first thing we have to do is find the semi-perimeter, which is 63 plus 48 plus 75 divided by 2. $63 plus 48 plus 75. Now I forgot to put parentheses for my numerator, so I'm going to press enter. Divided by 2 equals. Since I had a computation, I needed parentheses, but since I didn't put them, I can get that answer and then my answer divided by 2. So S is 93. So now my area is the square root of 93 times 93 minus 63 93 minus 48, and 93 minus 75. It doesn't really matter which order you do those in. And we'll just use our calculator for this. It's going to be the square root of 93 times 93 minus 63. Some of these you could do in your head. And don't forget, you're going to have to open and close parentheses. 93 minus 48 and 93 minus 75. So our area is 1,503 square feet. So it's a very easy formula to do. I'm going to do one more of those. We're given our triangle. So this is A, then side A is 26, side B is 35, and side C is 32. So we want to get S. S is equal to 35 plus 26 plus 32 divided by 2. It's equal to the semi-perimeter. So it's 35 plus 26 plus 32. And again, I forgot my parentheses, so enter, divided by 2, and I get 46.5. We do not round off here. We use the semi-perimeter, and it's either going to be a whole number or it'll be a 0.5. So it's going to be 46.5. But that's why I wanted to do this problem, was so that you know that you don't round off on your semi-perimeter. So we have 46.5 times 46.5 minus 32, 46.5 minus 26, and 46.5 minus 35. So we have second square root, 46.5, then open parentheses, 46.5 minus 32, close, open, 46.5 minus 26, close, open, 46.5 minus 35, close and close. So we get 399 square feet. Inches, square inches. So these are three different ways depending upon what you're given. If you're given two sides and the included angle, then we would use one of these formulas depending upon which two sides we were given. If we were given two angles and a side, then we'd find our third angle, and then it's the side squared times the sine of the adjacent angles divided by twice the sine of the opposite angle. If we're given three sides, then we would use Heron's formula. First of all, find the semi-perimeter, and then it's the square root of the semi-perimeter times the difference of the semi-perimeter in each side. And so that gets us three different ways of finding the area of a triangle that's fairly easy. Let's just look at one application here. We have a parallelogram. It says two sides measure 24.1 and 31.4, and it gives us the shorter length of the diagonal. What we want to do is to find the area. So if we look at our parallelogram, and we have a shorter diagonal. So our shorter diagonal would go from here over. Okay, let's label what we know. We know that the two sides, this side would be 24.1, 31.4, and then the shorter diagonal was 32.4. Now we want the area of the whole triangle. Well, we can't find that directly, but we can find the area of this triangle, and they're going to be the same. Remember, your diagonal bisects it. So then we would just double it. So we have three sides. So S is going to be equal to 31.4 plus 24.1 plus 32.4 divided by 2. So we'll get our semi-perimeter, 31.4. Let me just go back and put my parentheses like I should. 31.4 plus 24.1 plus 32.4. Close parentheses divided by 2. So we have 43.95. Now, I'm going to find the area without writing all of those steps down. It's going to be the square root of my semi-perimeter, 43.95, and then it's my semi-perimeter and the difference of my semi-perimeter and each side. So 43.95 minus, I'll just start with here, 31.4, close, open, 43.95 minus 24.1, close, open, 43.95 minus 32.4, close, close. So that area for that triangle is 355.6. I'm going to have two of those, so times 2. So the area of my whole parallelogram would equal 711.2 square inches. And so you can find then areas of figures. So these are some formulas that we have for finding areas of triangles.